Hello, ma'am. Assalamu alaikum. Welcome to our presentation. In operating system, a deadlock occurs when a process or thread enter a waiting state because a request system resources is held by another waiting process, which is turned in waiting for another resources held by another waiting process. That is called deadlock. So deadlock is very important part in operating system. So today our presentation topic is deadlock. So before discussing anything else, let me introduce ourselves. Ma'am, I'm Mehdi Hassan and my student ID is 20290202, and my another team member is MD Ziaul Haq, whose ID is 2029020021. So today our presentation contents are introduction, example of deadlock, necessary condition for deadlock, and last one is method for handling deadlock. So first of all, we have to know what is deadlock. Deadlock is a situation that occur in operating system when any process enter a waiting state because another waiting process is holding the demanded resources. Deadlock is a common problem in multi-process where several processes share a specific type of mutually exclusive resources known as soft lock or software. So this is the example of deadlock. So here we can see that let's understand deadlock with a real life example. Consider a one-way road where two cars coming from opposite direction have deadlock each other passes. Here the road is the resources required by car, and car getting to the other side of the road can be considered a process. Now one of the car can move further and have entered a waiting state. As it is a one-way road, both car cannot move forward at the same time. We can say that the road is a single instance resources. So this is the example of deadlock. Now I'll discuss about the condition for deadlocks. So the four necessary condition for a deadlock situation to occur are mutual exclusion, hold and wait, no preemption, and last one is circular wait. So first of all, we have to know that what is mutual exclusion. So mutual exclusion is a resources can be held by only one process at a time. In other words, if a process P1 is using some resources are at a particular instance of time, the same time, some other process P2 cannot hold or out the same resources are at the particular time. The process, this is called a mutual exclusion. Now I'll discuss about hold and wait. Hold and wait means a process can hold a number of resources at a time at the same time. It can require for other resources that are being held by some other process. Now I will discuss about the non-preemption. A, a resources can be preempted from the process by another process forcefully. For example, if a process P1 is using some resources R, then some other process P2 cannot forcefully take that resources. If it is so, then what's the need for various schedule various scheduling algorithm? The process P2 can request the resource R and can wait for the resources to the feed by the process. Now I will discuss about the circular wait. Circular wait is a condition when the process is waiting for the resources held by the second resources. The second process is waiting for the resources held by the third process. This is called circular wait. Now next part we'll discuss about discussed by my another team member, MD Ziaul Haq Zia.
Thank you, Mehdi Hassadi, give me opportunity to present part to my part. And now I will discuss methods for handling deadlock. And this part we split three section, and these are prevention, deadlock detection, and recovery and deadlock ignorance. And now we know that deadlock prevention. It means that we design such a system where there is no sense of having a deadlock and and now deadlock can be prevented by eliminating of the four necessary conditions, which is the mutual exclusion, holding and weight, and no preemption and circular weight. And now broadly explain first of all, mutual exclusion. It can be resolved as if the hardware property. For example, the filter cannot be simultaneously shared by several processes. This is very difficult because some resources are not shareable. Hold and wait. Hold and wait can be resolved using the conservative approach where a process can start and only if it has acquired all the resources. And the circular way. This means in order to remove circular way, we assign a number to every resource and the process can request all in the increasing order. Otherwise, the process must release all the high number equivalency resource and then make a fresh request. The last one is the no preemption. No preemption means we allow forcefully free preemption where a resource can be forcefully preempted. The preempted resource is added to the list of resources where the processing is waiting. The new process can be restarted only when it gains its old resource property. Priority must be given to the process which is waiting for the state. And now, second step of our topic is the deadlock detection and recovery. What we do deadlock, how to do recover deadlock detection and recovery, and this process through we do recovery and detection deadlock. In this case of deadlock detection, we can run an algorithm to set for the cycle in the resource allocation graph. The process of a cycle in the graph is a sufficient condition for deadlock. Deadlock recovery, a traditional operating system such as Windows does not deal with deadlock recovery as it is a time and space consuming process. Real-time operating system use deadlock recovery. And then last one is deadlock ignorance. It is the most popular method and it acts as if no deadlock and the user will restart. As handling deadlock is expensive to be called of a lot of codes need to be altered, which will decrease the performance for less critical jobs deadlock are ignored. Ostrich algorithm is used in deadlock ignorance, used in Windows, Linux, etc. And that's all up to me. And thank you for listening presentation.